So for this problem, it's a word problem. So we have talking about equation for the velocity, and we also need to figure out the displacement. So the velocity function, we know that the integral or the antiderivative of velocity is the displacement. However, we actually need to get the displacement function. So which means essentially we need to solve for plus c. Okay, so we're going to first find the indefinite integral first, and then we're going to use the second part of this statement, in particular this d of 0 equals 1, to be able to solve for our plus c, which then allows us to come up with the displacement function. So again, if we take a look at the integral of this, we want to find the displacement function, okay, is going to be related to the integral of v of t dt. Okay, so then that makes this function t e to the t squared dt. Now, again, this is not a standard integral, so we need to look for some other strategies. In this case here, we need to think of substitution. And again, if we think of our inside function here, does the derivative of that inside function account for the leftover outside piece of that function? Okay, and it does. So we're going to use a let statement here. Okay, so we're going to let u equal t squared. Du then is 2t times dt. And since our integral here has a t dt, we're just going to move that 2 over here. And now we have our t dt that we are looking for on the outside. We can now do our substitution. So that green matches the green. So then I'm going to rewrite my integral. My integral is going to be d of t is equal to e to the u. And then we can replace the t dt with our du expression, or du over 2. And that 2 divided by 2 can come on the outside. So I can go ahead and anti-differentiate this. Okay, and my d of t is going to be, well, my e function just stays e plus c, and I'm just going to move that up here, shift that up a little bit. Okay, so my d of t function is then e to the, I do my replacement, t squared plus c. So I've got my d of t function, but now I need to solve for the plus c. And in this case, I'm going to use my d of 0 equals 1. Well, if d of 0 equals 1, that means e to the 1 squared plus c equals 1. 0 squared, okay, equals 1, which means that 1 equals 1 plus c, c equals 0. So now I have my d of t function. D of t is equal to e to the t squared. So to answer the question now, I want to solve for the displacement when t is 2. So the displacement when t equals 2 ends up being e to the 2 squared, or e to the power 4. Okay, so the displacement at t equals 2. So t equals 2, d, the displacement equals e to the 4. Okay. Taking a look at tan x, okay, there is no derivative, or sorry, there is no derivative that gives you tan x. Okay, so there is no antiderivative that we know of yet. So what can we do? Well, there doesn't seem to be an inside or outside part of this function, but however, you did this in the previous example, we can express tan with sine and cos. So there's our sine x over cos x. Now we can kind of look at this and say, well, where's the inside part? Does the derivative of the inside accommodate the outside? So this is very similar to a previous question that we did, again with sine and cos, in that if we let the cosine in this case be our u, or the cosine embedded in a reciprocal function, the derivative will accommodate the remaining outside of that function. Oops, I'll do that in. So there's our inside, and this is our outside piece, which we can now replace with du. So I'm going to rewrite that expression again. The integral of 1 over u. Instead of cos, I'm just going to replace that with u. And then I'm going to replace the dx, the sine dx, with a times negative du. So I'm going to put the negative out here. Okay, so sine dx, I'm going to switch the negative, just kind of goes to the outside here. And then I'm going to replace that sine dx with a negative du. So there it is. There's my function. Now this becomes a standard integral. The derivative of log is 1 over u. So the integral of 1 over u is log. So we end up with negative log of u plus c. Okay. So it being an indefinite integral, again, we want to express this with x's. So I'm going to do replace my u with a cos x. So negative log of cos x plus c. Now this looks kind of strange that we start with a log and we end up with a tan. So I'm just going to double check this. Is this in fact true? Well, I take the derivative of negative log cos x plus c. The derivative is going to be 1 over cos x negative times the chain rule, negative sine x plus 0. So I get sine x over cos x. Yeah, that's what I started with. Check. All good.